software engineering arena for the last 25 years or so. I've done everything from capturing requirements, talking to customers, lots of coding, lots of testing, lots of integration, and anything else in between. I've done everything that's in the software development lifecycle. And I've been practicing BDD ever since it first came out. And I had many failures with BDD. I've watched it become unwieldy, too complex, too much effort, too much time spent on it, and people have given up. And I've tried and I've tried, and I've found out what was going wrong and the things that people do wrong with when they practice BDD. And I found out some anti-patterns, and I set up some rules and some patterns to make everything work. And I'd like to share this with you because BDD is so powerful and can be so beneficial to an organization that it's a shame not to use it properly. So with that in mind, let's begin. And the first thing that we can start with would be to, obviously, define what is BDD, what is behavior-driven development. And obviously, most of you have done BDD or are doing BDD. I can see a couple of you haven't done it or would like to do it, but haven't started, haven't tried yet. So what is BDD? Well, to understand BDD, we need to talk about toasts. Right, I burn my toast in the morning. I confess, I do it all the time. We got a new toaster a couple of months back, and I still haven't. I'm not used to the right dials. It's one of these digital ones. So I burn my toast. Yeah, I do it, and I take the toast off, and I get a butter knife, and I scrape it off, and then it's okay, right? Then it's all fine. But then my wife comes in, and she uses different bread than I do. She uses a softer bread, and it burns more easily. So what happens is that I do my toast in the morning, then she comes later, and she puts her toast in. And she doesn't change the dial, the temperature. So she burns the toast and she scrapes it off with a butter knife. And then she shouts at me because it was my fault, because that's the way it goes, right? And yeah, so I do burn my toast. I can't help it, can't help it. So what's it going to do with BDD? Well, traditionally, for the last few decades, the way we've been developing software, it's like this. We have some requirements, we have some thoughts about how the software should work. We tell the developers write some code that does what they think should be doing, and then they ship it out to the testing team, the QA team. And the QA team, have a look at the code, have a go at the code, and they say, okay, this is fine. Or more often than not, let's be honest, more often than not, they give it back to the developers and say, this is not working as intended, or this is broken. Other developers will go ahead and they will fix it. They will fix the broken stuff. They will give it to the testing team again. Other testers will say, well, yeah, this thing is fixed now, but that other thing over there is not working. So back it goes again. So we do this little dance, a little circle a few times, back and forth, and eventually the QA team is happy with the code and they will ship it out. They might ship it to a staging environment, or they will give it to the end users directly, or it will go for UAT. And the users will have a play with the code, and again, they might be happy with it, but sometimes they think, oh no, this is not what we expected. So they will ship the code back to the development team again. And the development team will fix it again, go to the QA, and eventually will go back to the users. And eventually, the code is as intended, it has no bugs, and does what the users expect it to do, right? So, does it sound familiar? What does it remind you of? So what we're doing here, we're burning the toast. We're burning the software development toast. We burn it, and then we scrape it with a knife, and then we eventually are ready to taste it, right? It's inefficient. I don't like burning the toast. So why do we do it? Why do we keep burning the toast and keep going back and forth and scraping all the burned bits off? Well, we don't have to. There's a better way. And this way is BDD. So with BDD, we do things differently. We don't do the inside-out development that we did, that we just described previously. So we don't go from the developers to the QA team to the users. We do the other way around. we do an outside-in development. So we start with the end users, then we shift the code to the QA team, and then to the developers. How do we do this? Well, we start with the concept of a feature, and we sit down with the end users and we write some features. And the feature is basically a quick description of some system behavior, some functionality that the users want or need. And once we have the features, basically we have a clear description in English or in any other natural language, it doesn't have to be English, of how we want a product to behave under certain conditions. And once we have this, once we have the features, the next step is to write some step definitions. And step definitions are basically just code, but it's code that goes and exercises the features. So if, for example, we have a feature that says something like, oh, the shopper will move an item from the shopping list into the shopping basket. Then we write step definition, some code, that goes and looks at the shopping list, picks up an item and puts it in the basket. And if this code works fine without anyone breaking anything, then we can say, hey, our code, our system does what it's meant to do. So once we have step definitions and we can actually verify the features, then we can write some code. So we write the code that actually goes and creates a website and creates a shopping list and creates a shopping basket and creates a functionality that allows us to move items from the shopping list into the shopping basket. Beautiful. So let's have a quick look at a feature. What's a feature? As I've said before, a feature is just a description of some functionality or some product behavior. And the feature has a title. A title is a short description of what the feature does. And the best way to describe it is to use the form some kind of specialist user, some kind of stakeholder, exercises some functionality. So we can say that, for example, if we're developing some software for conferencing, like the Icon 360, then we can say that we have a feature where the conference speaker needs to upload a picture to the profile. And that's the title, conference speaker uploads picture. Then after this, we can add any details we like. And this is free text, so we can add any information that helps the readers of the feature understand what the feature is all about. Anything that makes it clear, makes it less ambiguous, we put in here. So in this case, I just added a little user story. As a speaker, I want to publish a nice picture on my profile so that the people can, just can see who I am. Simple as that. A feature has one or more scenarios. And a scenario is a step-by-step plain language description of the product behavior for a specific condition. So we can have a scenario that describes what we call the happy path. And in our feature, when we upload a picture to the profile, the happy path scenario is that given I'm logged in as a speaker, I choose a picture from my computer and I upload it, and then I can see my picture on the profile. Simple, right? And as you can observe here, the feature is written in a structured way. It's not written randomly. It's not free text. So we have these steps here. We have a bullet list of steps, and the steps are in a structured manner. There are given steps, which are conditions, and this describes the conditions that we need to have in order to exercise functionality. Then we have some when steps, and when steps are the actions that we take to exercise the functionality. And finally, we have a then step, and the then step is about the expectation. It's about the outcome that we expect when we exercise the functionality. And as you can see here, the scenario is written in plain English. There's nothing special about it. Actually, you can write scenarios in any language you want, really. I mean, most BDD tools support dozens of languages, so it doesn't have to be English. But the point is, it's a natural language. It's a language that anyone can understand. So you can give this feature to your CTO, you can give it to senior management, the product owners, the end users, and they should be able to look at this and understand how the product behaves. And of course, we're going to have more than one scenarios in real life, because we're going to have the happy path as is presented here, and we will have alternate scenarios. So for example, in this scenario, we describe what happens if with the file we're uploading is of a certain type, JPEG or PNG, and if a certain size is less than 5 megabytes. So what happens if we try to upload a type that's not supported by the system? An animation, for example, a GIF file. Then we need a scenario that describes what happens then. What if we try to upload a large file, a file that's more than 5 megabytes? Then we have another scenario that describes what happens in that case. So we're going to have multiple scenarios in our feature. We're going to have the happy path and scenarios that describe alternate eventualities. Okay. So we have a feature. So the next step is to write some step definitions, and step definitions are plain old code. And it looks a bit like that. So we have some code here, and the code here is presented as Ruby code, but you can actually write it in Java, in Python, JavaScript, and many other languages. So the first line of the code is when I am logged in as a speaker. And if it sounds familiar, it's because it matches the first step in our feature. And what tools like Cucumber or JBehave or SpecFlow or InflectraCON, what they do is they go through the features, they read every step, and then they go through the code base, the step definitions, and they try to match the step to some code. So a tool like Cucumber will look in a scenario, we'll see, given I am logged in as a speaker, it will go into step definitions, it will find a block here that says when I'm logged in as a speaker, and then it will execute the code underneath. That's all it does, simple as that. And the code underneath, it just opens up a browser, goes to the login page, types in our email in the right field, types in a password in the right field, clicks on the submit button, and then just waits till we get a successful login confirmation message. And it's simple as that. And once we've done that, then we can run this code anytime. And anytime we want to verify that a login page works, we just run this step definition and via obviously a tool like Spira or SpecFlow, and you can tell us that, hey, this works or not, as the case may be. So why is BDD so awesome? Because everyone talks the same language, because the features are written in plain old English and anyone can understand them. And that means that the expectations, the system behavior is understood by everyone, users, programmers, QA, and our senior management. And what we've done by having features that match to step definitions is that we're mapping the requirements to specifications. And not just any kind of specifications, but executable specifications, because it's actual code that we can execute automatically anytime we want. That's a big win, because we can run our tool like Spira or Cucumber or SpecFlow, and it will go through our scenarios or through all our features, and it will tell us which ones work without any errors. And so it's measurable progress. And that's how we know the state of our system. That's how we know, hey, is our system working the way we said it was going to work in our features? How cool is that? And of course, because our features are so written in a structured, simple, plain manner, they can serve as documentation. So if someone stops you and says, hey, how does your product work? You just direct them to the features. Hey, read this. That's how it works. And because we have this communication, we have this expectations that are common and understood by everyone, then we get considerable fewer bugs. And there are cases of companies that have tried BDD properly and they have massive reduction in bugs. So I can hear you thinking now, well, if BDD is so awesome, so magnificent, why isn't everyone doing it? Well, that's a good question. In my experience, I've seen BDD fail quite a few times. And the main reasons why BDD fails, why it's not adopted by the organization, it comes down to two things. The first thing is that the scenarios, the features become unreadable. Why do they become unreadable? One, because there are too many of them. I once had a feature that had 45 scenarios in it. I'm not joking. So I was scrolling and scrolling, and there was no end to it. I didn't read it all, I just gave up. I couldn't be bothered. The other reason why people don't read the features is because they become too technical. So you see features that have things like description of databases in them. They start talking about APIs and the payload of the APIs, about HTTP status codes and all this. And you know what? If you start doing that, people like your product managers, your CTO, any end users, they won't bother with reading features. They won't understand them. And who can blame them? The other reason why BDD may not be adopted is because of the cost and effort with maintaining the scenarios. So what usually happens is that we have too many scenarios. Not only we have too many scenarios, but we have what we call brittle scenarios. So that means that when something in our product changes, the code changes, we need to go and update the relative scenarios because they break. And that's why we call it brittle scenario. And imagine if you have to do this with hundreds of scenarios, dozens of features, hundreds of scenarios, it becomes like a big load, really, that we can't handle. And people tend to give up and say, oh, this is too much trouble. So what can we do about it? Funny you should say that. There are a few things that we can do to deal with the unreadability and the high maintenance cost. So the first thing we need to do is we need to adopt certain principles. So there are some rules we can apply to a BDD development to make it work for us. The first rule, and if you decide to walk away from this webinar right now, if there's one thing you take away from this chat, this session today, please make it be this one. BDD is not about testing. BDD is not a testing methodology. It's a collaboration and communication methodology. That's what it's all about. Yeah, you get the testing, but the testing is a nice side effect. It's not what BDD is all about. I don't know if you bake cake. Has anyone baked chocolate cake? Yeah, I mean, I do sometimes. I'd like to dabble. So I bake the cake into the sponge and everything, and it's all nice and tasty. And then the chocolate sauce in a bowl, right? So I put the chocolate and the butter and the sugar and everything and mix it up. And I pour the chocolate sauce on the cake, and it looks lovely. It looks really nice. But there's always some chocolate sauce remaining in the bowl. So, of course, what do? I get a spoon and I lick it. That's what I do. I can't help it, right? I'm not sure how many of you do the same thing. But it's lovely. But the thing is, here's the thing, right? The chocolate sauce is not what I'm trying to achieve here. The chocolate sauce is a nice side effect. What I'm trying to get out of it is the cake. The cake is what matters. So the chocolate sauce is like the testing. The cake is a communication and collaboration you get out of BDD. Now, I can guarantee you, and I've said it many, many times, if you have the testing mindset when you practice BDD, then two things will happen. First thing, management will switch off. So your product managers, your CTO, they will think, oh, this is a QA and developer thing. It's nothing to do with us. We won't get involved with this. And they will just never read your features. They will never be involved. The second thing that will happen, you're going to get loads and loads of unreadable features. Why? Because when you start thinking as a tester, you're going to be thinking about, oh, we need to have 100% coverage. And you're just going to start fretting about technical details, about things like database and message queues and all that stuff. And your features will become unreadable. And features that are unreadable are useless features, right? So if there's one thing you take away from here today, let it be this. BDD is not about testing. Yeah, you can have testing out of it, but that's not what we're trying to achieve with BDD. The second rule is the 2080 rule, aka the Pareto distribution. And this is a distribution that manifests itself in different aspects of human behavior and resource management. So, for example, if you look at your Spotify playlist, you probably find that 20% of the bands in there account for 80% of your favorite songs in your playlist. In software development, we find that 20% of the users raise 80% of the defects. What does that mean about BDD? Now, if you look at a feature and you start thinking about all the scenarios, and say you come up with 10 scenarios for this feature, then 2 of the scenarios will be exercised 80% of the time by the users. So what does it mean? It means don't try to go for 100% coverage. Don't try to fret about every eventuality. Start with the two scenarios that are the 80% scenarios. Build up from there. Build up probability-wise. Don't try to cover every eventuality, every edge case. Rule number 3. Your feature should describe what the behavior of the system is, or the product, not how it's implemented. So the features describe the what is going on, not the how it's going on. I've seen features that have steps in them will say something like, when such and such happens, then a message is placed in the outbound queue, or a record is added to the database. Now, here's the thing. The end users, the people who exercise the features, they do not care about whether a message is placed on a queue or whether it's placed on a barge and pushed on the River Thames, or whether it goes on a database or somewhere else. What they care about is having notifications of events when they happen and that are clear and matter to them, and they care about the data being stored safely and securely. So when you describe your features, you describe the what is happening, not the how it's happening. Rule number 4. I presume that many of us here are software developers, or engineers, and QA engineers, quite technical people. And it's only natural when we write a feature, we think like software engineers, right? Or we think like QA engineers. So we start describing a lot of the technical details in the feature, a lot of the things that matter to us. The thing is, the things that matter to us do not matter to the people who exercise the feature, to the users who are going to go through the steps of the feature when they use a product. So make sure that when you write a feature for a final year student, for example, you are the final year student. You become the final year student. You think like a final year student. You expect the same things that a final year student does. If you write a feature for an antique seller, you are the antique seller. You think like them. Do not think like a software engineer. Do not think like a QA engineer. Because if you do, then you're going to write technical details in your feature. Your features will become unreadable. And unreadable features are useless features. The final rule, rule number 5, make sure you specialize your users. I cringe whenever I see a feature that says, given I am a user, what does it mean? It means nothing. It's a catch-all term. There's no such thing as a user, right? When you write your features, make sure that you specialize the behavior of your users. You're talking about a postgraduate professor. You're talking about a first-time buyer. Yeah, you're talking about a shopper who's got things in the shopping baskets. So these are specialist behaviors, specialist users, and they expect very specific things. If you start thinking about users in general, we're going to have too many scenarios to describe too many different behaviors that apply to too many different users. We're going to have too many scenarios. They're going to be very ambiguous. People won't read them. And unreadable scenarios are, over to you. Yeah, they are useless scenarios, basically. So make sure you specialize your users. So these are the basic principles of BDD. When we write features, sometimes we make mistakes when we write them, and we normally end up paying for these mistakes by having too many features and having brittle features. So there are some anti-patterns that I see that come up all the time. So let's have a quick look through these. The first anti-pattern is the CRUD anti-pattern. In case you're not aware, CRUD is a technical term that means create, read, update, delete. And we use it when we're talking about functionality that applies to resource managing. So we create, update, delete, and edit resources. So let's say, for example, we are creating a blogs website, something like Reddit, for example. And obviously, the first thing we need to do, we need to allow the bloggers to create, edit, and delete posts, right? Makes sense. So we might be tempted to write a feature that says blogger manages blog posts. And we have a scenario where the blogger creates a post, another scenario where the blogger edits a post, another scenario where there's a blogger deletes a post. And you look at this and you think, well, that looks fine, right? It looks okay. What's wrong with that? Well, what's wrong with that is that when we start delving into each scenario in more detail, we come up with many different sub-scenarios, sub-functionalities. So for example, we create a post, yeah? And we have a copy path scenario that says, I'm logged in as a blogger, I type some text, I click on save, it's all okay, right? But what happens when we try to include a large video file in a post? How does the system behave? Well, what do we need to do? So we need another scenario for this. What happens if we reference a user that's no longer in our system, that's been banned or has left the system? Okay, what was the system behavior then? What do we do then? What's meant to happen then? That's another scenario. So by the time you know what's happening, you got 4 or 5 scenarios just for the create post functionality. And the same thing happens for the edit post and the delete post. So at the end, you have 25 to 30 scenarios for your blogger manages blog posts feature. 25 to 30 scenarios for one single feature are too many. People will not read them. And if people won't read your feature, it's, yeah, you know what I'm going to say now, right? It's a useless feature. So how do we deal with that? Well, we break it down. We take all the different sub-functionalities and we put them as different features. So we have a feature for creating blog posts, we have a feature for editing, another feature for deleting blog posts. And we have 3 or 4 features, but are very short features, very clear, easy to read, easy to maintain. Beautiful. So another pattern that's very similar to the CRUD pattern is the composite pattern. And a composite pattern is a pattern that brings together many small functionalities. And a good example I often come across is the profile. I create a profile on a website. And of course, a profile, what does it involve? It involves creating a tagline, creating a bio, and uploading a photo of yourself, a picture of yourself, right? So we might be tempted to have a feature that says blogger creates profile. And we're going to have a scenario for uploading a photo, creating a tagline, and creating a bio. And again, similar to the CRUD feature, when we start actually delving more into the scenarios, we'll come up with different sub-scenarios. So when we upload a photo, what happens if the photo is not the right type? What's the behavior then? It's a separate scenario, yeah? What happens if the photo is too large? What does the system do then? Well, that's another scenario. So again, by the time we know what's happening, we got 4 or 5 different scenarios under each of these main scenarios. So we have too many scenarios for a feature. And again, how we deal with that, we break it down. So we get the different functionalities as separate features, one for uploading the photo, one for the tagline, one for the bio. And once again, we have small features, easy to read, easy to maintain. So the NFR pattern. NFR stands for non-functional requirements. So normally the requirements dictate how the system behaves. So they are functional requirements. They dictate the functionality of the system, but non-functional requirements are more to do with things like performance or security or cross-platform compatibility, things like that, really. So let's imagine that we have one of the features for a blogging platform, and it's that I can view all the posts for a particular author, right? And it's a very similar feature, but we have a requirement, a non-functional requirement that says that we need this feature to work the same way in many different platforms. On a cell phone, on a laptop, on a tablet, so on and so forth. So we may be tempted to write different features for each platform. So we have a feature where the reader views all posts on an iPad, another one where they view all the posts on a cell phone, so on and so forth, right? And the thing is, all these features are exactly the same, apart from one line. And that line is where we specify the platform, the device. So we have 10 15, 20 features that are basically duplicates, more or less, apart from this one line, right? How do we fix this? Well, the language that we use when writing features called Gherkin has a very nice little construct called scenario outlines. And what a scenario outline allows us to do, it allows us to parameterize an entity. So in this case, we parameterize the device here. And that's why we have the angular brackets here. So what we say, when I use a device, and then we specify in an examples table what the device could be. So the device could be an iPad, an Android cell phone, an iOS cell phone, etc., etc. Now, when we run this scenario through a tool like Cucumber or Spira, what it will do, it will run the scenario as many times as the values we have in the examples table, as the rows in the examples table. So it will run it once, and it will replace the device that we got here with an iPad. Second time, it will use the Android cell phone. Third time, the iOS, so on and so forth, right? And of course, we need to have step definitions that account for these steps. When I use an iPad, for example, we need to have a step definition that goes and runs a code on an iPad, or at least an emulator. So what we've done here is basically we've taken this 10, 15, 20 scenarios and we compress them into one readable and maintainable scenario. How cool is that? Okay, so we have the another very common scenario. I see it again and again and again. It's the technical detail scenario. And we talked about wearing many hats, right? And if you don't wear many hats, then what will happen? We will write scenarios like this. So say we are developing a book buyer website, and we have a feature where someone can search for a book. So what we say here is that given I'm a book buyer and I visit a particular URL, then I see a search box that has the specific ID. This is a CSS ID, an HTML element ID. And then I go type my search terms and I use the composite operator for searching, the plus here. And then I click on another button called search and I'm redirected to another URL. Yeah. Now this makes perfect sense to me, but I'm a software engineer, right? I understand what's going on here. If people that are not technical read this, they will not know what's going on here. They won't have a clue. So what do we need to do? We need to make sure that this feature is readable. Remember we said we need to focus on the what is happening, not the how is happening. That's what we need to do, because the end user don't care about URLs. They don't care about HTML element IDs. They don't even know what redirect is, probably. They don't care. They just want to do a search, find the book, see the book. And that's what we do in here. That's why we write a feature. So you can see here that I'm not saying that I go to a specific URL. I visit a search page. Excuse me. Now, I don't care what URLs for the search page. I really don't. The user don't care. They want to go to a predefined page where they can search. Now, when they search, they want to type of search terms, right? They don't particularly care about what the join operator is, if it's a plus, if it's an ampersand, or whatever. It could well be that we have a button, an and button in our website that goes and adds the terms one at a time. It doesn't matter. What matters to the user is that they type in two separate terms, an author and a title term. And then they choose to search. Now, note here that I'm not saying they click on a button, I'm saying they choose to search. So I'm not depending on the button ID, because the button ID will change. Some other developer three weeks down the line will change it, and then my feature would break. So I'm saying they choose to search. When I describe the features, I describe the what is happening. I choose to search. The how is happening, that's for the step definitions to figure out, right? It's not for the features to specify. So, and again, just think that next year we might decide to do the search by voice activation. If I'm specify here that I'm clicking on a button, then my feature will break. What we're doing here by describing what's going on, the functionality and the behavior, rather than implementation, we future-proof our feature. Make sure it's resilient to changes. So that's a technical anti-pattern. And finally is the vague outcomes anti-pattern. Now, let's go back to our Blogger platform. So we have a feature where the blogger can change the title of the blog post. And it's very simple. They go to the blog post and they change the title, and then they can see that the edited blog post has been updated. What does that mean? The edited blog post has been updated. I assume it means that now the title has changed, right? But then again, I assume that. I don't know. And of course, you know what assume means, right? It's a bad thing. So what do we need to do here? We need to be specific and we need to use examples. So let's rewrite our feature. Let's write it like that. So now I say that given I'm a blogger, I don't just edit my post. I have got a post that's called Gone with the Wind. I pick this post and I change the title to Casablanca. I save my changes and then I see that the top post is called Casablanca. So now I'm saying here, hey, when I edit a post, it goes up the top of the list, the top of the list of posts, right? It moves up the post, moves up the list. And I say the background color is now green, yeah? So hey, there's a visual indicator to show me the post has now changed, it's been updated. And there is no post title Gone with the Wind. So here I'm just making sure that, hey, I'm not duplicating things here. The post has not been copied. The previous post is gone. The new post is now called Casablanca, and it's new because of a green color. I am specific. I specify exactly what's expected, what the outcome is. And not only is it easier to understand how the behavior works in this case, it's actually easy to verify. Yeah, so when I come to write step definitions, I can know exactly what I expect to find. So at the top of the page, I expect to find the new post called Casablanca. The background color will be green. And then I can do a search and we'll find no post called Gone with the Wind. Easy, easy peasy. So, and these are the anti-patterns. There are many more anti-patterns, but these are some of the most common ones that I've encountered in my career. There's one more thing I want to talk about. It's a little bit technical. I'm only going to spend 2 minutes on it, so don't panic. It won't be too much. It's about writing step definitions. There is a way to make sure when we write the step definitions, they are less brittle, more resistant, and more reusable. And this is called code layering. Let's have a quick look. So when we write our features, we have 3 layers of features, right? We have the domain layer, which is where we specify the features. This is the behavior. This is the business end of the behavior. So given a user is logged in as a shopper and he has 3 items in a basket, etc., etc. And then we have the operational layer. The operational layer is what happens when we say user is logged on as a shopper. Well, what does it mean? It means when I say user logged on as a shopper, it means that the user have gone to the login page, they've entered some credentials that match, they've got a shopper permission, and they are logged in as a shopper. That's what it means. And what we can do, we can wrap this behavior up in what we call a page object. And the page object is a design pattern, and it reflects the functionality of a specific page. So we can have a page object for a login page, another one for our checkout page, another one for our payment page, etc., right? So we separate the operational behavior, and then we don't have to say all the time whenever there's a step that says users logged in, we don't have to go and say, hey, go to this login page, find this element with the username, enter the username, do the same for the password, click on the button, blah, blah, blah. No, we don't do that. All we do, we create a new page object And then we call a method called login, and we pass the username and the password. And that's that. And what that means, it means that we can reuse a page object again and again, but it also means that it's much easier to change, because when something changes in a login page, we only need to change it to one single place. We don't have to change it everywhere. And this makes the effort and time spent on changing features, maintaining features, a lot less. And another pattern we can use is a facade pattern. And it's very similar, same principle as the page object, but we wrap up a user journey or part of the user journey in a facade. So then we can call it whenever we want to, and we don't have to be repeating the same steps, and we don't have to be changing the same steps again and again. We would only change the facade whenever it needs to be changed. Okay. Again, if you want to talk more about that, I'm more than happy to talk about it offline, but we don't need to go too much down the technical details of this. So this brings us near the end of our presentation. So we talked about what the pitfalls are with BDD and what we can do to succeed with BDD. The first thing we talked about is whatever you do, make sure you don't think of BDD as a testing methodology. If you do that, bad things will happen to you, right? So make sure that your BDD is applied at the start of your life cycle. So whether you use Jira or Trello or whatever else you use for requirements, make sure you capture your features in there, and make sure as part of your acceptance criteria, you have the scenarios. Because once you do that, you have very clear, plain, readable, testable, executable acceptance criteria. And what that means is that then your requirements, if they capture those features, they drive everything else, your design, your implementation, your testing, and how your product evolves. They drive your whole life cycle in a traceable way, in a way that can be read and understood by everyone in your organization. The second thing we talked about is the 5 principles. And again, we said BDD is about the what, not the how. Think about the 20% of the scenarios that are used 80% of the time. Describe the what is happening, not the how is happening. Wear many hats. Be your user. And make sure that your users are not generic users, they are specialist users with very specific behaviors and requirements. And then we saw some features. We talked about the crowded code with the features, where we break down features into smaller features. We talk about avoiding duplication with the by using scenario outlines, the examples table. We talked about avoiding technical details in the feature, and we talked about being very specific about the outcomes of what we expect from the feature. And we also had a very brief description of layering the step definitions using design patterns. Basically, what we do is separate the code that changes a lot from code that doesn't change often. And thereby, we ensure that our step definitions are less brittle, more maintainable. And that kind of wraps up our session for today. I'm not going to guarantee that this will 100% make sure you succeed with BDD. I do guarantee, though, that if you start applying these principles and look out for these patterns, then you will be far less likely to fail. You won't be bending your toes as much. Put it that way.
Thank you very much,
I'd like
Fred.
to thank you for your time. And Jessica, over to you.
Yeah, we do have a question in the chat. This is going back to the rules that you discussed. And we have a question that states, in regards to rule number 2, how you balance adding some negative scenarios, that the scenarios are not just all happy path.
So the question is, how do we balance the edge cases with the happy path scenarios? We don't.
Yes.
We don't. In every feature, we'll have 1 or 2, maybe 3 happy path scenarios at most. The rest of them will be alternate scenarios, will be basically things that go wrong. So when we write a feature, we always assume some conditions. So if, for example, we look at the feature here, we upload a picture to a profile, we're assuming that the file we upload will be of a certain type, it'll be of a certain size, right? So to write alternate scenarios, we start thinking about, okay, what if the file the user chooses is not the right type, it's not the right size? What do we do then? What's the system behavior then? Now, this is a plausible scenario, right? Because this can happen, and this does happen. Someone will click by accidentally, maybe will click on a Word file, right? Instead of a picture. They will do that. That's a plausible scenario. Now, what I'm talking about when I say the 2080 rule, I'm thinking about start with the plausible scenarios, but don't go too far down the edge cases. So in this particular example, we could think, for example, we could think what happens when the, I don't know, to use a very extreme example, what happens if the user's internet goes down, right? Well, it can happen. Yes, it can. But it's an extreme scenario, right? This is not testing. What we're trying to do here, we try to define core behavior. So we want people who read our features to understand the behavior of our system, how this product behaves under most circumstances, right? If we want to have extreme edge coverage, that's where the unit test come into place. This is not unit testing.
We have another one here. When do we sit together and write the AC in terms of BDD? Backlog refinements, grooming?
Sprint planning and grooming, yes. So whenever we change the backlog, which is during the sprint planning in Scrum, and during the refinement, that's where we change for the acceptance criteria. And many teams have a definition already, which means that basically they won't put things in the sprint that haven't got acceptance criteria, right? That's what I try to instill in my teams. If something doesn't have acceptance criteria, you're not going to work on it. And I make sure the acceptance criteria are the actual scenarios. So this would be an acceptance criteria here. And of course, we can translate this to the actual code via a tool like like Cucumber or Spira or whatever. And we have this kind of full-on traceability and full-on QA. We know that when we deliver our code, we can run all these features through the tool, and we can see what doesn't work. And if it all works, then we're happy because we said we delivered what we said we were going to deliver.
And we have one more here. Have you observed a favored or optimal method of discovery to prime scenarios?
Yes, I have. That's a very good question, actually. What I do usually, I try to I start with a happy hour scenario, which is obviously easy and very obvious, and then I look at all the assumptions we make in here, right? So, for example, here it's very clear to see the assumption we're making is that I have a file of a particular type and a particular size. So the obvious question here is that, okay, what happens if the type is not of this, of the file is not of this type or is of a bigger size? What do we do then? So I'm trying to invert the scenarios. So I'm trying to look at the steps and say, okay, what if the step is not true? What do we do then? That's the way I normally go about it, if that answers your question.
Thank you very much. Well, that seems to be it in our chat, and that's perfect timing because here we are at 1 minute prior to the hour. Thank you all for joining us today. It was wonderful to have you here. And thanks, Fred, very much for your insight on BDD. I hope it was helpful for everyone. And Fred, we hope to have you again at some point.
Thank you very much. Thanks everyone for your time, and thank you for attending.